There we go. Okay. All right. So here's what we're going to talk about for a minute. Okay. All right. So in trig, there are a lot of different trig classes. This is kind of what we would call trig 1, right? Like the intro to trig. And if you go back and look at the name of this course, it's not trig, it's plane trigonometry. Not plane as in not fancy, but plane as in a plane, like a two-dimensional situation, a plane trigonometry. What this means is we're studying different planes in the math world, okay? Now, the only plane you probably know that exists is the rectangular coordinate system. That's the plane that you have been put in since elementary school, okay? So the rectangular coordinate system has X. You learned all about X, right? And then we introduced Y, and then we told you you could make little points with them, right? And in the rectangular coordinate system, we told you you could graph them, because to graph in the rectangular coordinate system, you have two number lines. You have the X number line, we keep him horizontal. We have the Y number line, we turn him upside down vertical, and then we plot stuff, right? You guys have been doing this forever, okay? This is all rectangular coordinate system. If you see X's, Y's, your axes, points like this, you're in the rectangular coordinate system. Okay, so how do you graph a point in that? Well, let's say we gave you 2, -3, okay? You have some kind of catastrophe over there? You all right? Oh, okay. So, okay, so let's say you have the point 2, -3. Okay, you know how to graph that, and I know you do, but it just kind of helps if we talk about it for a minute. So we know we're going to go horizontally to the right 2, and we know we're going to go vertically down 3, and there's our little point, right? We know this. This is the rectangular coordinate system. Okay, very cool. Well, now we're going to talk about a new coordinate system. Now we're going to talk about the polar coordinate system. So this leaves the rectangular plane and goes to another plane called the polar plane. Okay, so you kind of think of it like worlds or like video games. Like this was level 1. Okay, you started out, you learned this, got a little harder as you move through the game. All right, now you're at the end of that level. You completed that world, right? Like you got the princess out of the castle, or you killed the alien, or whatever you had to do. And now we're leveling up today. Okay, we're in another level. We're now going to polar world. Okay, that doesn't mean we're cold. It means that we're going into circles. Polar deals with circles in math. So now we're headed to polar world. All right, so this is everything that happened in rectangular world. Now we're headed to polar world. Polar world is different, okay? So now we're gonna have the polar coordinate system. Well, the good news is I've been baby stepping you through the polar coordinate system since January. You just didn't know it because I've kept you on a little short leash, but you already know all the stuff that happens in the polar coordinate system. We don't have X's and Y's. We have R's and thetas, okay? Well, you already know theta. That's just an angle. It can be a positive or a negative angle. You already know R. R would be the radius of a circle. So you know everything there is to know about the polar coordinate system, except for one last little piece, okay? So first, before I give you the end of the whole thing, let's kind of go to our packet for just a second and look at this little picture. All right, let's look at this little picture. So here in this little picture, we are going to be in the rectangular coordinate system. So we're back to level 1, right? We're on world 1. Okay, so here's our X, here's our Y. Let's say that we wanted to plot this point, which just happens to be point XY. That's the point we plotted. So we went horizontally X, we went vertically Y, we got to this point, okay? What you know from trig is that not only is that point sitting there in quadrant 1, but you could take his X distance and his Y distance and make a right triangle out of it, right? We learned that kind of in the beginning of trig. And we said then if we take and do a diagonal from the origin to complete our little right triangle, this distance is r, right? So in the last chapter, we talked about a squared plus b squared equals c squared. We're going to move away from that now. We're going to go back to where we were, where we know for a right triangle, we could also say x squared plus y squared equals r squared. We could also say that, right? All right, so we kind of used this explanation from the rectangular coordinate world to create our unit circle, right? Because we said that a unit circle is an infinite amount of these right triangles all the way around. Remember, we talked about how that was one way to kind of talk about the unit circle. And because it's a unit circle, what was our R for a unit circle? 1, because it's 1 unit. That's the definition of the unit circle, okay? Well, then what we were able to do is say, okay, this is theta. This would be positive theta. We could also do negative theta. And then what we could do is if we set right here, we could say, okay, sine of theta is going to be y over r, or opposite over hypotenuse. We said we could also define cosine as adjacent, or x, over hypotenuse, which is r. Remember that? We said we could define that. And then it got super easy in the unit circle because our r was 1. So cosine was x and sine was y, which was super great. Okay, so we developed all of this stuff using these polar situations, this r and this theta, in the rectangular world. Okay, so what does the polar world actually look like? This is what the polar graph actually looks like. Okay, now I have degrees around it. I don't have radians because I couldn't find one that had both, but you know, it could be radians, it could be degrees. This is a polar coordinate graph. All it means is that you start with a dot in the middle. This little dot in the middle is not the origin, okay? It was the origin in the rectangular coordinate system. Now we call that little dot in the middle the pole. We're polar, this is pole, okay? Then from the pole, you have an infinite amount of circles that come out of it. It's kind of like a spider web, is really what it looks like, okay? So an infinite amount of circles that come out. Then starting from the starting place, not the x-axis anymore because we're in polar world, just the starting place, you can create theta, an infinite amount of positive thetas and an infinite amount of negative thetas. And then you can also graph in polar world, okay? So in polar world to graph, your point would have to be r theta. And you're going to do theta first, and you're going to do r second. Now, don't worry, we're going to do tons of examples, and this is written throughout your packet. I just think it's nice if you get all the info at first, and then we'll baby step through it. Okay, so let's say, for example, this was your point. They wanted you to graph in polar world. Okay, kind of looks weird, right? But that's the point. Okay, first thing you're going to do is 45 degrees. So you're going to start here, and you're going to go up to 45 degrees. And then you're going to create what we call a polar axis at 45 degrees. It just means you put a line there coming from the pole at 45 degrees. Then this tells you the radius or how many circle hops you're going to go out to put your point. So this would be 1, this would be 2, this would be 3. You're just going to hop out that many circles, and there's your point that you graphed in polar world. Does that make sense? So you're going to go to your theta, and then you're going to hop out that number of circles, because this would be a circle of radius 3. So it turns out you've been in polar world for this whole class, but you were living right here. This is the unit circle right here. Think about it. It's got all the angles, and it's got a radius of 1. So you've been living here the whole time. I just didn't tell you because you're on a need to know basis. Okay, so now you've leveled up and you get to know this. Yeah, Okay, so here's where you were. Your R was 1. Now you have been unleashed and you can go anywhere you want in polar world. Okay, but just remember your R is not 1 anymore. Your R can be anything. Does that kind of make sense how to deal with things a little bit? Okay, we're going to talk about it a little more in just a second. The other thing I want to tell you that in rectangular coordinate world, your R had to be positive, right? Because it was a distance. In polar world, your R can be negative because I don't want you to think of it as a radius so much as a movement, either forward if it's positive or negative if it's backwards. So what if I gave you this point instead? Okay, 45 degrees, I make my polar axis, it's still here, but now I'm not moving forward 3 hops. I want to go backwards 3 hops. Okay, well, then what I do is I just take this polar axis that I drew and I extend it straight backwards. Usually they extend it backwards with little dots, like a dash kind of situation to indicate it's going backwards, but I can't really do that here. But anyway, so I'm just going to go straight back. And then I want to go -3. So I'm starting at the pole. Instead of hopping forward 3, I'm going to hop backwards 1, 2, 3. This is the point, -345. It's still on the 45-degree polar axis, but you hopped backwards instead. Okay, so you can go forward or backwards. All right, I can tell you're fascinated. Okay, one other little point I want to make is that rectangular coordinate system, if I drew this first and said, I want everyone in here to tell me what this point is, label this point. Everybody in here is going to come up with the same answer because there's one right answer in rectangular coordinate world, right? It's +2, -3, one right answer. So that means everything in rectangular coordinate world is unique. There's only one right answer. Polar coordinate world, there's an infinite amount of correct answers because think, but I'm gonna narrow you down. But think about it. Okay, think about it. If this is our point here, okay, our R is 3. We know that. So this theta could be 45 degrees. What else could it be? No. Okay, so it could also be, all right, it could also be a whole nother rotation, right? We could add 360 to that 45 degrees. I'm feeling really unable to do basic math, so I'm just gonna, okay, so it could also be 405 degrees because we went 360 degrees plus 45, right? We could add another 360 degrees to it, or we could even go backwards. I could say, okay, what if I want to do, again, I'm sorry that I'm not able to do basic math. Okay. It could also be -315 degrees. It's the same point because now all I did is I went backwards 315 degrees and I went up 3. So it's got all kinds of variations and what it could be. Does that kind of make sense? I know that sucks, but that's kind of how it is. Now they're going to rein you in and just give you little concise things that they want your angle to be. But there it is. Okay, so it could be a lot of different things. You can add 360 and spin around a million times. You can subtract 360, spin around a million times. What about the negative situation? I could even take it further and say, this point right here, I could call it -3, 225 degrees. Okay, well, if I'm here and I go 225 degrees, my polar axis is now here, okay? But instead of moving forward on it, guess what I'm gonna do? Hop back 3, same point. So I can do this a lot of different ways and come up with the very same point. Now we're gonna have to have some really clear directions on how to get all these multiple points. I'm gonna give you that in a minute. But what I want you to kind of understand now is that polar world, it's like the wild, wild west, right? Like anything goes. You can do all kinds of stuff over here because remember the unit circle. I can add or subtract my 360 degrees. And now what you're finding out is that you can also have forward movement and backward movement. So that's also going to change your theta a little bit. Okay, so it's kind of different. All right, let's go to our packet then and kind of talk more about it. All right, so here we go. Okay, so your polar coordinate system, you have a point called the pole. That's the center. That's the origin in rectangular world. Then you have a polar axis. That's going to be wherever your theta is that you're drawing out, okay? So for example, here's your pole, here's your polar axis. And then you're going to have a point somewhere on there that's going to correspond to R, okay? All right, so we also have to be able to go back and forth between these worlds. We need to be able to go from rectangular to polar easily. That's going to be the key to you doing well in this chapter. Can you give me rectangular coordinates if I give you polar coordinates? Can you give me polar if I give you rectangular? Can you switch back and forth between their equations? How well do you understand how they connect? This little box is the key, okay? So over here, we already know this is true, right? Because we already said, oh yeah, that's kind of from the unit circle, that x squared plus y squared equals r squared, right? It's just that now we can't say that they equal 1. We have to say they equal r squared because r can be anything. All right, we also know from our unit circle that if this is tangent here at theta, opposite over adjacent gives us y over x. We know that. We also already know these. We proved them over here. So remember, we said that sine theta is y over r, but we're not in the unit circle anymore. So we can't say sine theta equals y. We can't call r 1. We have to leave the r. So how do I solve for y? I would multiply both sides by r, and then I get y equals r sine theta. I can multiply both sides by r for the cosine, and I get x equals r cosine theta. So we know all of these formulas already. It's just that we were calling r 1 when we were dealing in that inner circle. And now we have to keep it r because it could be anything, okay? It is, it's all coming back. All right, so here we go. These little definitions are going to be my math lab question number 1. It's going to ask you about the pole and the polar axis. Okay. These 2 little definitions for x and y, that's going to be my math lab 2. Okay. Hold off on my math lab 3. It's on another page. This little factoid here is my math lab number 4, which we already talked about. We said that rectangular coordinates are unique, right? There's one right answer to that. Polar coordinates have infinitely many answers. So polar coordinates are not unique. They're going to say, are polar coordinates unique? No, right? Okay. All right. So how do we get those multiple polar coordinates that I was showing you on there? How did I come up with those so quickly? All right. Well, here it is. There's 2 choices. You can keep the same r, whether it's positive or negative, and then add or subtract a full rotation, right? We said that. I can keep my r, and then I can either add or subtract a full rotation. Okay, what if we want to do a negative r? We can do a negative r by adding or subtracting half a rotation. That's how I got this dude here, okay? So if my original point was this, and I wanted a negative r, the way that I get theta is I take 45 and I add 180. And oh, you can see, okay. And that gives me the 225. Or I subtract 180. So if you're gonna do a negative r, you have to add or subtract 180, and that's going to give you the same situation. Okay, we're going to practice that in a minute. I just wanted to show you that. So here's how you find those multiple points, because they're going to ask you to give a multiple point for a coordinate. And here's your two choices to do. Okay, let's flip it over and do my Math Lab 3, number 3, which is example 1. Okay, so example 1 is your My Math Lab 3. Here we go. So we have a point that's in a polar coordinate because it says 9 pi over 6. This is r theta. And sometimes polar is in degrees and sometimes it's in radians. So it could be either one. Okay. So this wants you to name 2 other coordinates that are exactly the same. That's what it wants you to do. Okay. So first of all, I thought what it might be nice to do is graph this guy. I didn't give you a graph here, but let's flip it over and use the graph on the other page. So let's just use this little polar guy down here. Okay. So here we go. All right. He's in degrees, but if you recall, our point was 9 pi over 6. What's the degree for pi over 6? Anybody remember? 30. Good. So this is really 930 degrees, same thing. Okay, so I know it's kind of hard to see on here, but this would be 30 degrees. So this is going to be your polar axis right here. Okay, now 9 is R. So I didn't give you 9 circles, but guess what? Just like on a rectangular coordinate, you don't have to make each little tick mark 1. So we can make any tick mark we want. We could like draw an extra circle in here. We could draw an extra circle in here. I'm just trying to come up with 9 circles so that it doesn't end up all over my page. You don't even have to draw the whole circle. You can just kind of draw half the circle. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. There's our point. We graphed it. Okay. So all you got to do is somehow come up with 9 little circles and hop on out there, and there's your point. Okay. Does that kind of make sense? All right. So what I want is 2 other points. Okay. Well, I could get 2 other points by leaving the same r, which is 9. And then for my theta, I can add 2 pi or I can subtract 2 pi. Okay, so that's one way I could come up with 2 other points, right? So if I wanted to leave the same r, I could take pi over 6 and I could add 2 pi to it. Okay, so if I take pi over 6 and I add 2 pi, I'm not going to actually add 2 pi. I'm going to add 12 pi over 6, right? Because we need to have the same denominator. So that would give me 13 pi over 6. That would be, okay, one of the same points. Okay, I could also take pi over 6 and I could subtract 2 pi. That would give me negative 11 pi over 6. So that would be 2 additional points that mean the exact same thing. Okay. All right. What if I wanted, though, to have the opposite r? Okay. So if I wanted to have the opposite r, if I wanted to have a negative 9, okay, then I'm going to need to take my theta, which is pi over 6, and I'm going to either add pi or subtract pi to it, right? That's how I use it to get the, if I'm going to use a negative r. So I would have pi over 6 plus 6 pi over 6. That would be a point. Or I would have pi over 6 minus 6 pi over 6. That would be a point. Okay. So I actually came up with 4 points. You can choose any 2 you want. You can choose the 2 with the same r. You can choose the 2 with the negative r. You can choose 1 positive and 1 negative. You can do it any way you want to, okay? because again, there's an infinite number of right answers. So it's perfectly fine. Now let's look at this one just to make sure you understand how this works. 7 pi over 6 is actually 220 degrees right here, okay? So if I came around and made this my polar axis right here, instead of moving forward 9, I would have to move back 9, and that's what gives me that same point. Okay, does that make sense? It's kind of strange, I know. I'm just trying to keep you guys awake and focused at the same time. I'm juggling a lot of balls in here. Okay. All right, so that is this problem over here, even though we kind of did it on the other page. So you can name any 2 problems that you want to use. Okay, I didn't ask you if you still needed this. Does anybody still need all this writing down here by chance? Is everybody good? Okay. All right. So now we're just going to kind of focus on plotting points in the polar coordinate plane. I'm going to give you a bunch of points. I'm going to see if you can plot them. That's it. Now on my math lab, like this is my math lab number 5, because remember number 4 is on the other page. This is what the polar coordinate plane looks like. But guess what my math lab gives you? The rectangular coordinate plane. So I just kind of want to show you, all you really need to do is think like this and then stick it over here where you think it would work. You aren't going to actually have to graph it with a graphing tool. You're going to have multiple choice and you pick the one that matches it. That's all you got to do. Okay. So let's ignore this for a minute and let's look at this. Now you may look at that and be like, that looks just like a rectangular coordinate point. How do I know that's polar? Well, because you're going to have to read. Okay. Because a lot of these look exactly like rectangular coordinates, but they're polar. So that means my R is -11 and my theta is 0. That's what that means. Remember, you do theta first. So where is 0? Right here. Okay, so here I am. There's my polar axis. Okay, but we want to do -11. So I don't want to hop forward toward the arrow 11. Where do I want to go 11? Back the other way. So just kind of pretend you're putting in, they do this a lot. Instead of drawing a whole circle, they'll just do the little curve of the circle. I'm going to hop back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And there's my -11 way back there. Okay. So this is the picture of -11, 0 in polar coordinates. Anybody notice something? It looks exactly the same as a rectangular coordinate, right? You went left there, right? And it looks exactly like -11, 0 if it were a rectangular. Anytime your theta is 0, they're going to be exactly the same point. So that's just a little helpful fun fact for you. But okay, so when it comes time for you to get on my math lab and match up which one it is, it's not going to look like this. Yours is going to be 1, 2, 3, 4, 5, 6, 7. Oh, good gracious. Just pretend that these have little tick marks in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It's going to look like that. Okay. So you're just going to have to notice, okay, I know it's supposed to be this, but this is what I'm going to mark on my math lab. Okay. And that would be that you plotted it correctly. Okay. On a rectangular graph. Don't you love my math lab? We're actually doing away with my math lab next year. So if you have another math class, you won't be dealing with it anymore. We're going with a different program, but yeah, we're just really on the game. Okay, here we go. Example 3. Now we're getting a little more polary. Okay, this would be number 6 in your my math lab. Okay, we gave you a polar coordinate. He's definitely polar coordinate because we've got a big old fat theta there, right? Okay. Remember, you want to do theta first. So 11 pi over 6. This is why I gave you a unit circle. Not because we're staying on the unit circle. It's because most of y'all never memorized it to begin with. So where the heck's 11 pi over 6? Well, this way, with your unit circle, you can look over here and go, oh, there he's in quadrant 4, right? And he's like 330. He's like down here. So that's why I gave it for you, so that you can go, oh, sure, Miss Holcomb, here's 11 pi over 6 right here. Okay. So that's why I thought you might want to have one of those, just so that you know where some of these radians are. Okay, so here's our polar axis. This is 11 pi over 6. My radius is 5. So here we go. You're going to either have to draw in some more little circles there or make a couple bigger ones. But I'm going to move forward 1, 2, 3, 4, 5. There's my point. So that's what it should look like. But on my math lab, you're just going to have to somehow go kind of pretend that would be the picture that you would want. I know it's bizarre because it has no rhyme or reason with a theta, but you're just going to have to know, okay, that's kind of quadrant 4. That looks like it lines up. That's the one I'm going to go with. Okay. Now, in your My Math Lab, it may look like, let me show you a couple options. It may look like this. It doesn't even have an arrow on the end of it. It just has that point like a ball on the end of a line. So, okay, like a tether ball or something, right? So that may be what you see. My Math Lab gets even weirder. Sometimes they just put the dot, like they're back in rectangular coordinate world, which they are not. So just kind of keep in mind, this is the correct answer, right? But anything that's over there in quadrant 4 that looks sort of right, just click on that, okay? Everybody do that? Okay. All right, let's try these next two. Okay, let's do these next two together, because look at the point. It's exactly the same theta. Look at your R. One's forward motion, one's backward motion. So we want to make sure that we can do these, you know, together. So this would be like number 7. This would be like number 8. Okay, so here's my R, here's my theta. Negative 5 pi over 3. Okay, so again, here's where your unit circle comes in handy. Here's positive 5 pi over 3, right? It's almost a full rotation. It's 300 degrees. It's almost a full rotation. You're in quadrant 4. So if I'm going backwards 300 degrees or almost a full rotation, what quadrant is my polar axis going to be in? 1, right? Because positive 5 pi over 3 is this way in 4. So negative 5 pi over 3 is going to be up here in quadrant 1. Okay, so here we are. And again, it doesn't have to be exact, just get it in the right quadrant because it's just multiple choice. This is going to be your negative 5 pi over 3, okay? Negative 5 pi over 3. Then we want to go 4 circles forward. So 1, 2, 3, 4. That's what we're looking at. It's just like that. So somehow on my math lab, you're going to end up with something that looks like this, or it might just be a floating dot in the middle, but it's going to be in quadrant 1. Okay, sound okay? All right, let's look at the same point, but this time with negative movement. So we're still using this polar axis, this negative 5 pi over 3, but we're not going to hop forward 4. We're going to go backward 4. So now what we're going to do, normally they just dash it out the back like that. And then they go 1, 2, 3, 4, and there's your point. Okay, how in the world is my math lab going to represent that? You ready for this one? Okay, so what they do is they use black to show the original angle. Then they use red to show the backed out angle. And then they put a ball on the end of it. So just kind of do your best with these My Math Lab questions. At least they're multiple choice. But if you kind of, you know, can graph these on a polar axis in your mind, at least you can match it up. Does that sound okay? All right. Okay, so I think you got the handle of the points. Everybody good on the points? How to graph polar axis wise or polar coordinate? Okay. So now let's go back and talk about these relationships. When are we going to use the box? Let's use the box now. Okay, so we know all these. Of course, it wouldn't hurt to put these on an index card when it comes test time, right? Because we forget everything. But here we go. All right. When you are moving from a polar coordinate to a rectangular coordinate, you're going to use these top two. Okay, this is going to let you go from polar to rectangular. Polar to rectangular, these two. When you want to go the other direction, from rectangular to polar, you want to use the bottom two. Okay. And then we want to be really careful with this little sentence here. All right, because polar can be so wonky, because it can have so many different coordinates, right? And a positive and a negative R and all kinds of things. We need to be really careful that we are conscious of the fact, are we in the right quadrant? That we really need to be careful, because even though your coordinates for polar and rectangular are going to look very different, they're still going to be in the same quadrant. Quadrant 1 in polar is quadrant 1 in rectangular. Quadrant 3 in polar is quadrant 3 in rectangular. So we want to kind of keep that in mind and make sure that we're in the right place when we start going back and forth. Okay. All right, here we go. So first, this is, oh, I guess no, that's not right. Let me see. That was 6, 7, and 8 on that page. Okay, this page, this is my math lab 9 and 10. It's not like this is 9 and this is 10, I think, or I can't remember which one it is. That might be switched, but this kind of situation here, you're going to end up with a lot that look like 9 and 10. So I didn't want to write them right next to the other one because I can't really remember. All right, so here we go. We have polar coordinates of a point, 13 pi over 2. Okay, this means our r is 13, our theta is pi over 2. Now, before we start switching over and converting, let's think about where this point is in our mind. Where is this theta located? Pi over 2. Anybody? You can look at your unit circle, but where is pi over 2? Yeah, it's like 90 degrees. It's this positive portion of the y-axis. Everybody agree with that? Okay, and our r is positive. So what I'm looking at is the positive part of the y-axis is where this point is located. 13 moves up on the positive part. Okay, I just want to make sure when we convert this to rectangular that that point is the same. That's like your checkpoint. All right, here we go. All right, so we have our theta. We want to go to xy. That's what we're trying to do, is find the rectangular point that's the same. Okay, so if I'm going polar to rectangular, I'm using these two formulas. Okay, so to find x, I'm going to do r cosine theta. Okay, easy enough. I've already labeled r and I've already labeled theta. So I'm going to have 13 times the cosine of pi over 2. Okay, well, you can go to your unit circle. Here's pi over 2. Here's the point. What's the cosine at pi over 2? 0, right? Cosine's x, sine is y, right? So we're going to have 13 times 0. Okay, so x is going to be 0 for our answer. Does that make sense how we got that? Okay. All right, now we're going to do y, which is r times sine theta. Okay, r is 13 times the sine of pi over 2. Okay, I go back to my unit circle. Okay, pi over 2 is here. Sine is going to be 1. Okay, y is 13 times 1, which is 13. Okay, before I circle this and say, absolutely, that's correct, let's think about where is 0, 13 on our rectangular axis. Okay, so 0, I don't go left or right, and I go up 13. So where am I located? Positive y-axis, just like we should be. So that is correct. See how I kind of just checked it to make sure that it was in the same location as your polar point? Okay, all right, let's go down here. Try it again. Okay, again, this is one of those weird ones, right? Where we have to make sure, is this polar or is this rectangular. But if you read it, it tells you it is polar. It just so happens that your theta is 0. Okay, we want to find the rectangular coordinates. All right, I already told you the answer to this one earlier, but let's just work it out so we can make sure we remember. All right, so x equals r cosine theta, so negative 13 cosine of 0. Okay, I go to my unit circle. Here's 0. Cosine is 1. Okay, so x is going to be negative 13 times 1, or just negative 13. Okay. Y is going to be r sine theta. So negative 13 sine of 0. Okay, I go to 0. At 0, my sine is 0. Negative 13 times 0, y is 0. Okay. So if you recall, we already talked about the fact that if your theta is 0, it's only when it works. If your theta is 0, your rectangular and your polar coordinates are exactly the same. Okay, so we didn't actually have to do this, but I just wanted to show you that it is true. Okay, they're going to be exactly the same. All right, let's do 2 more and then we'll go the other way. Okay, everybody okay with that? All right, so now we're going to have 11 and 12. Okay, the last 2 where we're going to go from polar to rectangular, and then we're going to go the other direction. So it says these are polar coordinates. So here's my r, here's my theta. Wants us to find x, y. Now, before we jump right in, I should have done this with the other one, but I knew our answer was going to be the same. Let's figure out where we are. Let's figure out what quadrant this is located in, because we want to make sure we're in that same quadrant. So my theta is 3 pi over 4. Okay, that puts me here in quadrant 2, right? This would be my polar axis. But look at my r. It's negative 4. So am I going to stay in quadrant 2? What quadrant am I actually going to be in? 4. Because what I'm going to end up doing is hopping backwards 4. So that point is actually in quad 4. So you just kind of want to make a note so that when you go to do your rectangular coordinate is also in quad 4. Okay, so here we go. I'm going to do x is r cosine theta. Okay. So I go back to my unit circle. I need cosine of 3 pi over 4. That's negative root of 2 over 2. Oh, now we're getting a little tricky, aren't we? Okay. All right, here we go. If you want to, you can do the whole thing out like this. Negative times a negative is a positive. I can reduce here. My x is going to end up being 2 root of 2. Oops. Okay, everybody okay with that? Let's try y. All right, my y is going to be r times the sine of 3 pi over 4. Okay, if I go back to sine of 3 pi over 4, sine is positive root of 2 over 2. Okay, that's going to be negative 4 root of 2 over 2. It's going to reduce to negative root of 2 over negative 2 root of 2. Okay. 2. Okay. Before I circle them, would this point be in quadrant 4? Yeah, I think it would, because let's think about it. Okay, I'm gonna do it this way. I have a positive x and a negative y. Sure, that's quadrant 4. Looks good to me. Good enough. Okay. All right, let's look at number 9. Okay, here we go. I have an r and I have a theta. I need to find x, y. Okay, let's figure out what quadrant we're in. Negative 2 pi over 3. All right, here's positive 2 pi over 3, right here in quadrant 2. It corresponds with 120 degrees, okay? If I go negative 2 pi over 3, or negative 120, what quadrant does that put me in? 3. Does that make sense? Okay, I got up to here the positive way. I'm going to get down to here the negative way. Okay, so I'm supposed to be down here in quadrant 3. I check my R, it's negative 3. Am I going to stay in quadrant 3? No, I'm going to hop backwards and I'm actually going to be in quadrant 1. No, you're looking at me like I'm crazy. Okay, let's think about that again. All right, so I have negative 2 pi over 3. Okay, positive 2 pi over 3 is right here. It's like 120. If I have negative 2 pi over 3, I'm going to go negative 120. That's going to put me right here at like 240. Everybody okay with that? Down here. So this is my polar axis, is right here. This is negative 2 pi over 3. Now I look at my R. My R is negative 3. I'm not going to hop forward 3 on here and stay in quadrant 3. Where am I going to hop? Backwards. And that's going to put me in quadrant 1. That's where I'm going to be. Okay, I'm going to be in quadrant 1. So I just need to make sure that's where I end up. That's my little checkpoint. That one's really tough with all those negatives in there. Okay, here we go. I'm going to do an X. I'm going to have R cosine theta. Okay. All right. So again, positive 2 pi over 3 was here, but I want negative 2 pi over 3. That's going to put me right here. If you don't like that negative 2 pi over 3, remember, you can take 2 pi and just add that to it. So if I wanted 2 pi, that would be 6 pi over 3 minus 2 pi over 3. That's going to be 4 pi over 3. And you could use 4 pi over 3 instead. And there you go. If you like to do that better, if you want to get rid of that negative angle. So my cosine's negative 1. My sine is negative root of 3 over 2. Okay. So I'm going to have negative 3 times negative 1/2. My x is going to be positive 3/2. That's my x coordinate. Okay. Now we want y. So we're going to have r times sine theta. Again, if you don't want to use that negative 2 pi over 3, add 2 pi to it and you'll get a positive theta. And then you can just go there if that makes it better for you. Okay, this is going to be negative 3 times negative root of 3 over 2. That was my sine for that point. So my y is going to be a positive 3 root of 3 over 2. And that's my answer. And they're both positive, so I'm definitely in quadrant 1. So I just wanted to check and make sure that's where I ended up. Okay, everybody okay with that? That was a tricky one. All right, example 10 is going to go fast because we know the trick. This is like 13 in my math lab. Now they're giving you rectangular coordinates. So this is your x, this is your y. They want you to change it to r theta. Okay, what's the trick? What's my answer going to be if my rectangular is 21, 0? They're going to be the same. They're going to be the same. Remember, if your y is 0 or your theta is 0, they're both exactly the same point. Okay, they're both the same point. You can go through and do the switcheroo if you want to, but you don't have to. All right, let's do number 11 because I want to just show you why I keep stressing these quadrants. Okay, so 11, 12, and 13 are going to be like 14, 15, 16 in your My Math Lab, but they're kind of mixed around a little bit. Okay, so now we're going to go the other direction, and we have to pay attention. So this says rectangular, so this is x, this is y. We want to find r theta. Now they have to put some restrictions on you because otherwise everybody in here would have a different answer and it would be super hard. So what they're going to tell you is do a positive r, make them positive, okay? And they're going to tell you make your theta within one rotation positive or one rotation negative. So don't get all crazy and wonky, okay? What they're going to tell you. Okay. All right, so if you look back at your little box, we said these are the two formulas we're going to use to go this way, from rectangular to polar. So that's what we're going to be dealing with, are those two. All right, so first thing we need to find is an R. Here's our formula to get R, right here. Okay, just so happens we know our X and we know our Y. Okay, so a -2 squared is a +4. A +2 squared is a +4. That gives us a positive square root of 8. Now you can't use square root of 8. Hopefully you know better than that. You're going to have to reduce it. What's the square root of 8 reduced? 2 root of 2, right? 2 root of 2. Okay, so our R is going to be 2 root of 2. You don't ever have to worry about negative R's. Okay, but now we need a theta. So to find the theta is when we're going to use this little guy. Tan theta equals y over x. Okay, so we're going to have tangent theta equals 2 over -2, y over x. It came right out of my point there. Okay, we're going to reduce it a little bit. Tan theta equals -1. Okay, now is when we have to choose the quadrant. We didn't do that. I forgot. So let's go back here. What quadrant is -2, 2 in? -2, 2. Quadrant 2. That means this polar point better be in what quadrant? 2. That means we're going to be looking in quadrant 2 for this theta. Has to be in quadrant 2. So I'm going to go to quadrant 2 and I'm going to look for the theta where tangent is -1. So here I am in quadrant 2 only, because what you're going to find is you're also going to be able to find that same value in quadrant 4. Don't go down there because your rectangular point says you're up here. You got to stay in quadrant 2. So which one of these values, let's just stay with theta, would give you a tangent of -1? 3 pi over 4. Because remember, tangent is y over x. So it would be this over this, this over this, this over this. The only one that's going to give you a -1 is 3 pi over 4. So your polar coordinate is 2 root of 2, 3 pi over 4. So going that direction is a little bit tougher. As you can see, it requires a little more thinking. So your R is going to be pretty easy. It's positive R. Your theta, you have to decide what quadrant you're in first and then stick with that quadrant only. Then when you're in that quadrant, look and see what theta gives you that value of tangent. And then that's the theta that you're going to use. Okay, so you won't be able to do all your homework